Hello, science enthusiasts. I'm Jason Zakowski.
And I'm Chris Sikowski.
We're the pet parents of Bunsen, Beaker, Bernoulli, and Ginger,
the science animals on social media.
If you love science
and you love pets,
you've come to the right spot. So put on your safety glasses
and hold on to your tail.
This is the Science Podcast. Hi, everybody, and welcome back to the Science Podcast. We hope you're happy and healthy out there. This is episode 24 of season 7. We didn't have a podcast last week because the technology failed, Chris.
We were going to try a new thing. It's called the video podcast. All the cool kids are doing it, and it didn't record the appropriate level of sound quality. So we're looking into that and how we can improve that. So then we can join all the cool cats and kittens next week.
Yeah, exactly. So we'll try that next week. We had a very busy week, exciting week. We were in the mountains. We were driving to Edmonton to shoot this dog training course with Marla Smith. So that was fun. It was a very busy week, and we're just now round 2 of this episode, which we did last week and nobody heard because it sucked. The audio was terrible. All right, what's on the show this week? This week in science news, we are going to look at the Squamillaria plants, which are fun plants in Fiji that stop ants from going to war with each other. This is actually a really cool study. And in pet science, we are going to be looking at how pets may help folks who are doing like occupational therapy and physical therapy. All right, let's get to it. There's no time like science time. This week in science news, we're going to talk a little bit about mutualism. Now, in Alberta in grade 9, one of the things you have to teach is symbiosis. And you've taught Science 9 before.
Yeah, I sure have. I love that unit in biodiversity because actually a lot of the kids like it too, because it's animals and fun and it makes a lot of sense. And
genetics. The kids love the Punnett squares.
They love genetics, and it's just a really great time to teach and really great content to teach.
Yeah, exactly. My favorite things in the whole symbiosis isn't mutualism, which is what this story is about. It's parasitism. Because I can show a whole bunch of creepy videos and make the kids squirm. And a lot of them really like it. But today we're talking about mutualism. Mutualism, of course, is where you have two animals living in close proximity and they both benefit from their interactions. And we are looking at the relationship between a whole schwack of different types of ants and the Squamillaria plant. This was a study led by Durham University. Now, this plant belongs to the same family as coffee. Go coffee. I think you and I are on Team Coffee.
Team Coffee.
And quinine, which I think makes quinone, which might help with malaria. Don't quote me on that. This is found in tropical Fijian trees growing as these fat aerial tubers, and they're sometimes the size of a basketball. And I burst out laughing when I read what they're named by the locals in tradition Fijian language if you translate it. They are called, now cover up small children who are listening, they are called the testicle of the tree. And if you Google image Squamillaria plant, that's what it looks like. Not to get too graphic, but there you go. They have leafy shoots and they act like an apartment building for the creatures that live inside them.
And the creatures that live inside them are ants. And the ants sublet the different compartments because it's a unique situation where multiple species can live there. So the tubers, they do host multiple ant colonies. And interestingly, they can hold up to 5 genetically distinct ant species, which is a surprising level of diversity in such close quarters. So we talk about niche in Science 9, and we talk about high diversity in the highly specialized areas near the equator. And then we talk about the broad niche up north where we live, where the level of diversity is not as unique as close to the equator.
No, if you go outside in January and you start poking around for animals, you're going to find two, maybe.
You're going to find like this snow hare and
yeah,
maybe
you're going to find a rabbit and some
moose.
birds that should have left long ago. There's some snowbirds or something.
Yeah. They're like fly south
Maybe
for
a
winter.
moose. On Christmas morning, there was a moose hanging out in our bushes. So
Yeah, in
that's
our yard. It was a Chris Moose. Merry Chris Moose Miss.
yeah, it just about died because I walked right up to it because it was in our dogwood eating the stems.
You're
Anyways.
like, moose.
Yeah, you got that on the Ring camera. That was crazy.
That is crazy. But we're talking about the testicle of the tree here, the tuber. So the plant's inner structure contains multiple isolated chambers, each holding a separate entrance, and there's no internal doors that are connecting the chambers. And so that design is excellent because it prevents contact and conflict, which maintains peace between potential ant rivals. But when the walls between the chambers were broken during research, ants from the different colonies immediately engaged in deadly battles, which often resulted in all of the colonies dying within 30 minutes.
Whoa.
It was a fight to the death.
You know, that there's a scene in Saving Private Ryan that I'm reminded of. I'm sure you've seen Saving Private Ryan with Tom Hanks and Matt Damon.
Yeah, I've seen that movie.
Yeah, there's like a point where they're at the midway point and they're trying to track down this Private Ryan guy. And the American squad guy, they look in a building and he leans up against this brick wall and the brick wall falls over. And they're fighting in this town, like building to building. Anyway, this brick wall falls over, and behind the brick wall is an entire squad of Nazis. So they look at each other for a second, and then, yes, it's a deadly battle where a whole bunch of people died. It's like those ants. They were right beside each other, not knowing each other was there. But as soon as they saw each other, all heck broke loose.
Terrible.
It also reminds me of some of the stories you said where you and your sister would fight so bad you had to go to restaurants where there was a partition between your legs so you couldn't.
Oh, yeah. The restaurant called Spuds right across the line.
Okay.
Yeah. It had a brick wall between, so my sister and I couldn't kick each other under the table.
Yeah, because that's a deadly battle. They did CT scans and dissections to show the plant's architecture and how it prevents conflict by strictly separating them. So there was no way for ants in apartment block A to mess with ants in apartment block B. The plant may also chemically deter the ants from chewing the walls. There could be something in the wall that tastes bad. Ants have mandibles that can chew through lots of stuff. And why wouldn't they just chew through this plant? No, maybe it tastes really bad. The idea is that compounds like calcium carbonate are things that ants don't like to chew on. Perhaps this plant is just like full of it. And some ant is, you know what? I'm just going to eat the wall. And it tasted bad. And he told his friends, so they stopped doing it.
And the plant evolved going, hey, the ants don't seem to like this, so we're just going to keep making it.
Exactly. But obviously the ants get a house. And with how expensive houses are today, that's good for these younger ants. But what does the plant get from this interaction? The ants have to go to the bathroom eventually, and they are messy eaters. So they leave behind droppings, food scraps, and litter. And all of those things decompose and enrich the plant. It delivers things the plant maybe wouldn't normally get. It would get normally nitrogen, but it could get more things like nitrogen and phosphorus. It absorbs them through the wall. So from one person's trash, another person's treasure.
One ant's poop to a healthy tuber.
Okay.
Well, there's been evolution of the, what?
Poop to a prize.
Poop to a prize. The evolution of the ant-plant partnership has evolved. So in newer plant-ant partnerships, only one ant species lives in the tuber. So that means there's no need for walls, just a single shared chamber. And another thing that has evolved is ants planting seeds in nearby tree bark, and they guard the seedlings, which acts like little tiny farmers. That's super cute.
They got to grow a house, right?
Yeah.
This brings us to a cool kind of conclusion that nature doesn't always conform to what we think, where one thing evolves and another thing evolves. Both species benefit, influencing each other, and they just get better together. You and I are both teachers, Chris. I'd imagine with seating plans, we do the same thing with kids that don't get along, or if they're next to each other, they're up to no good.
I guess I do randomized seating plans every month. And normally I don't run into problems where students can't sit beside each other. So I just knock on wood that can continue.
Oh man, what kind of like consequence would that be? I was like, you got to go in the testicle in one of these 5-section rooms if you're not paying attention, and you have to be cordoned off in this little room. I guess it's like when you kick a kid out, like they're just out of control, which has happened before, and they got to go to the principal's office.
Or go sit in the sad chair.
Go sit in the sad chair. All right. There you go. It's a cool kind of mutualistic relationship there. And that's science news for this week. This week in pet science, we are going to be looking at a pretty wholesome study that investigated the effects of a facility dog in physical therapy. Now, both you and I have had to have some physical therapy in our life. I hurt my back helping my parents move the first time pretty bad. Not as bad as you. You actually seriously injured your back when you were moving your classroom one time.
I actually moved my classroom from one end of the hall where I called it was Beverly Hills because it was so nice. I had 2 windows, lots of light. And then I moved down the hall and then I had 1 window, so not as much light. I was like, oh, this isn't quite as nice as my Beverly Hills classroom. I had to move out the door into the real world. And I moved into a different classroom at a different school. But I'm going to do it for myself first. So what I would do is I'm like, no, I got this. I can do this. And I grabbed a Rubbermaid tub, and books weigh a lot, paper weighs a lot. And I lifted it and I turned and I tweaked and I said to myself, I'm sure going to feel that tomorrow, but I didn't think anything of it. So I packed all my stuff. I put it all in the van. Away it went. And then what happened is you and I walked around New York all summer. Like we went on a really nice holiday. And then I got home and my back was a little bit sore, but I thought that's okay. I can go for a run. And I did. I can run. And then like it all was a disaster. I came home and you said, why is your spine shoved over to one side?
Yeah, you look like an S.
Yeah, you said, why are you an S? And I said, I'm not an S. And you're like, no, your whole body is shifted to one side. Look in the mirror. And then once I looked in the mirror, it was devastating. Because I did look like Pablo Picasso.
No.
And
you had a lot of physio that you had to do.
Yeah. And I'm always very careful. I don't want to hurt my back again because it's very painful going for that physical therapy.
Knock on wood, I have not injured my back in a long time. I think most of my injuries were like I did something in martial arts and then I did something right after it. A lot of jumping and flinging yourself around in martial arts, and I've retired from that. But back to the study, it might have been nice to have a facilities dog while I was doing some of my rehab from my injuries. And just as a reminder, a facilities dog is a highly trained canine that works with a handler in things like courtroom houses, schools, or hospitals. And they provide support and comfort. So very cute, very good dogs. This study was aimed to explore whether a facility dog could help overcome barriers in inpatient rehabilitation. So this study is from Physical and Occupational Therapy in Pediatrics.
And the type of study was a randomized controlled crossover trial. And they had 69 inpatients recovering from a variety of acute conditions. So acute meaning quite severe. Now, 69 inpatients or an N of 69 isn't a lot, but that just leads us to maybe suggest, hey, this is a great area to explore, and subsequent studies can look at this as well. What they decided to do was have patients performing one of 5 common rehabilitation tasks, and each participant completed the same task twice during a rehabilitation session. And then there was a random assignment, which determined whether the facility dog was present during their first or their second trial.
Oh, man. Can you imagine you're in pain and you go to get some physio, do some physio, and you're in the group that doesn't get to see the dog? That would suck, because I love dogs.
They would have had to agreed to be part of it. And so they would have had to know that there was a potential for a dog.
And potential for no dog. Like, that would be disappointing. So the facility dog was present along with the handler and a physical therapist. The control condition involved only the physical therapist and the handler, no dog. So I guess the handler stuck around to watch you do your exercises. They measured your task persistence. So that's the time spent engaged in the rehab task. And some of the rehab tasks like aren't super fun. Like I had to roll on my back on this foam thing. I have it. It feels really good when you're done, but while you're doing it, it can be sucks. So I get that. Like you do it for longer. Your self-rated pain, so how much you're in pain that you think, self-rated exertion, and physiological measures, which include your heart rate. They ran some statistical analysis, and what did they find, Chris?
They found that participants persisted approximately 2.6 minutes longer when they were working with the facility dog. They also found that participants without a dog at home also persisted significantly longer with the facility dog present compared to those who already owned a dog.
Okay.
And continuing, both measures varied by task order and dog presence, as we said before, and they looked at the pain and the heart rate results, so the physiological results. So the first task with the dog, the pain and the heart rate were lower, and then the second task with the dog, the pain and heart rate were significantly higher. So that suggests a possible shared physiological response to cumulative effort or arousal.
Oh, so the second time around, people had more pain.
Yeah.
Okay.
Yeah. So that could be because they've already gone through it once, and it does hurt the first time you go through. And so doing the task again talks about your response to that effort.
Maybe they just wanted, after the first time, they're like, you know what? I just want to pet the dog.
Or I want to show off for the dog.
Oh, okay. There you go. So that's why your heart rate was higher.
Some interpretation of this study could be that the presence of a facility dog may improve patient participation, and that could be because of cognitive factors. So they were distracted from the discomfort, which increased the focus on the task, and emotional factors. So having a positive emotional response elicited by interacting with the dog. And I know that would be me. And I know I get distracted if I go for physio, because my physiotherapist will talk to me all throughout when he's going in and getting those muscles loosened. And he's talking to me, and sometimes I can't talk through it. It's too painful, but it's definitely a distraction than if he was just going at my lower back muscle and for 45 seconds with no distraction.
Do you think having a dog there would be better if you could pet the dog and see the dog? I think it would be better.
I think it would be better too.
Oh, yeah. I think I would be more likely to go into physio if I knew a dog was there rather than not. Because some people skip physio because it is painful. It's stretching, moving those muscles, and that you've done something to.
Exactly. Come for the dog, stay for the pain.
Yeah. Bunsen, Beaker, Bernoulli would not be good facility dogs right now. Because if you were ever showing pain, I think they would just try and come and stop what was happening, especially with you. If somebody was doing something to you and he looked like you were in pain, I think Bunsen and Bernoulli would freak out on that person. They'd think they were hurting you.
You know what Beaker would do?
What?
Would lick your hand.
I know.
She would fling up her head and want you to pet her. That's what she would do, because she's a sweetheart.
Yeah. All right, there you go. That's pet science for this week. That's it for this week's show. Thanks for coming back week after week to listen to the Science Podcast. And a shout out to all the top dogs. That's the top tier of our Patreon community, the Paw Pack. You can sign up in our show notes. All right, Chris, let's hear those names that are part of the top dogs.
Amelia Fettig, Ree Oda, Carol Hano, Jennifer Challen, Linnea Janik, Karen Cronister, Vicky Otero, Christy Walker, Sarah Bram, Wendy, Diane, Mason and Luke, Helen Chin, Elizabeth Bourgeois, Marianne McNally, Catherine Jordan, Shelley Smith, Laura Stephenson, Tracy Linebaugh, Anne Uchida, Heather Burback, Kelly, Tracy Halberg, Ben Rather, Debbie Anderson, Sandy Breimer, Mary Rader, Bianca Hyde, Andrew Lynn, Brenda Clark, Brianne Hawes, Peggy McKeel, Holly Burge, Kathy Zerker, Susan Wagner, and Liz Button.
For science, empathy, and cuteness.
Let's go adventure in the deep blue sea.